Welcome to an example where we have a building and an angle theta. It says a building that is 225 feet tall casts a shadow of various lengths as the day goes by. Okay, is that making some sense here? What I could do is let me just add a little space in here in the top. Or actually, you know what? Maybe let me just move it a little bit. Yeah, that'd be better. Okay, so in other words, the sun is way, way up here in the sky, right? Shining. And what happens? As the rays come down, that's terrible. Sorry, my artistic skills are not the best. So, boom, they hit right there, and this creates right here a shadow, doesn't it? But as the sun goes down, in the afternoon, the sun goes down, down, down. Well, that's too far. Let's just go just a little bit. As the sun goes down later, what happens to that shadow? You see what's going to happen? Here's the ground, right? So that shadow gets longer. See how the shadow, as the sun goes down, you get that idea? We're gonna have a lot of questions like this. As the sun goes down, the shadow gets longer and longer. And you've seen that. They talk about that in movies and popular culture, as the shadows grow long. That's the afternoon because it's blocking the rays. This building is blocking the sun's rays. All of this will be in shadow, and then all of this will be in light, right? Okay. So that's the idea. Let me back off this later thing and just say, okay, right now the sun is where it's at. We got the shadow. And it's saying an angle of elevation theta, that's an angle of elevation because it's from flat up. That's what an angle of elevation means, from flat up. Okay, is formed by lines from the top and bottom of the building, the tip of the shadow as seen in the figure. Find the rate of change of the angle of elevation with d theta dx. Okay, so to do that, step number one, we need we need a relationship, a connection between theta and x. So as you look right here at theta and you look right here at x, what could we do? Well, do you see this is a right triangle right here? And I can just move this 225 right here. It's the same thing. It's the height of the building. So this right here, let me try to draw it clearly for you. Um, this right here is a right triangle, isn't it? Do you see that? And so remember for right triangles, we can use SOHCAHTOA. Remember that from trigonometry? That's for any right triangle because it has H, hypotenuse, which always means side opposite right triangle. Now remember how the little trig review here. This is the side opposite of the angle theta. This is the side across from the right angle, so this is the hypotenuse. So this shadow must be the adjacent side. Remember that? Adjacent means it's next to theta. So this side is next to theta. This side over here is across from it. It's opposite theta. And the one across from the right angle, that's always the hypotenuse. Okay. So what then? How do you know if you need sine, cosine, or tangent? Well, here's how you know. You need a connection between theta and x. What is x? The adjacent. And what else do you know? You know the opposite. You don't know the hypotenuse. We have no idea. So we don't want to use the hypotenuse. We have no idea about the hypotenuse. We just know the opposite is 225. And the adjacent, the shadow, that's what we want. That's our x, right? So we want a trig relationship between adjacent and opposite. Which trig relationship involves adjacent and opposite? Tangent, right? This means opposite adjacent. So step two, that means tangent of that angle theta, remember this from trig, is what? It's going to be 225 over x. That's opposite over adjacent. The tangent says opposite over adjacent. That's the meaning of SOHCAHTOA. Remember that? Opposite over adjacent, 225 over x. So there is a relation, a connection, an equation between theta and x. Got a theta, got an x, got an equal sign in the middle. That's it. When we say relationship, we really mean, equation. That's what we want. Something that connects them. equation related. Okay, so there we go. Great. Okay. But now step three, we need to solve for theta. How do you know? Because we're supposed to take the derivative of theta. So I need theta alone. The theta. I'm trying to find, or you can go down here. This is theta prime. So yet I got to get theta alone. So how do I take that relationship? Tangent theta equals 225 over x. I want to get rid of that tangent so that I can solve for theta, right? This is like, it's like left side, right side. Trying to make that better. Left side, right side, theta's saying, I want to be alone. Get rid of that tangent so I can be alone. That's what we got to do. How do you get rid of that tangent? Could you just divide by the tangent on both sides? No, 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 no. I see that a lot. Remember, this is not multiplication. Tangent with theta, you might say, well, there's no symbol, it means times. No, remember, whenever you have something right after sine, cosine, tangent, or any other function for that matter, f of x, g of x, that's plug in to the tangent function, right? It's like I always call it like a toaster. This, a tangent is a toaster. It's a function. You plug stuff into it. That theta is plugged in. It's not multiplied. That doesn't mean tangent times theta. And because it's not times, then you can't divide. It's not times, you can't divide. It's plugged in. That's how functions work. What comes after a function? Sine, cosine, tangent, fx, g of x. That's plugged in like bread plugged into a toaster. It's not multiplied. So, okay. Well, what do you do then? How do you get rid of the tangent? Do you know? It's tangent inverse. And whatever you do to one side, you have no choice but to do the same thing because that's the opposite of tangent. That's why we have inverse trig functions because we got to do that kind of thing. So there we go. So what does this mean then? So we have theta is now alone. It's tangent inverse of 225 over x. So, okay, so far so good. We got an equation between theta and x. There it is. Step three, we solve for theta. Theta is alone. Now we're ready to take the derivative. So let me bring down a little more room here. All right, it's derivative time. So we got theta equals the step four derivative. Theta equals tan inverse of 225 over x. Now the derivative, theta prime. There's the derivative. What does it equal? Well, what's the rule for tangent inverse? Remember the rule for tan inverse? Tan inverse, the derivative, is 1 over 1 plus x squared. So you go, okay, okay. So it's going to be 1 over 1, whoops, 1 over 1 plus x squared. Now, this whole thing is the x, right? Whenever we write a math formula, a science formula, I should have said x here. Whatever is there goes there. So this is going to be the whole 225 over x squared, right? The whole thing squared. But um, the inside here, the inside is not a simple x, which means you got to do the chain rule. So we're not done. Times the derivative of the inside function. Yeah. Hold on. Let me back up. See if we do, if we, so first off, are you understanding what I'm saying? Whenever the inside, well, let me put it here. Whenever the inside is not x, we must, oops, scribbly there. We must do the chain rule. That's what the chain rule says. If the inside is not simple x, then you got to do the derivative of that piece right there. That's the chain rule. Now, how do we take the derivative of this piece right here? Well, it's a fraction. So we got to use the quotient rule. That's a pain. You know what? I'd rather avoid that. So I'm gonna do a little trick here. I'm gonna change this. Instead of 225 over x, I'm going to make life easier for us. I'm going to write this as 225 x to the minus 1. That way that we don't have a fraction. That's the same thing, right? X to the minus 1 is the same thing as x on the bottom. And it's easier to deal with because it's not a fraction. So again, this will be, come back here. Here, let me just bring it down here. Sorry, it's getting messy. So the derivative, theta prime. Again, how do you do the derivative? You go 1 over 1 plus whatever's plugged in. So it's 225 x to the minus 1 squared. But the inside is not a simple x. I got to do the derivative of that inside. Bring it over here. So it's going to do the derivative of 225 x minus 1, the inside. Because that's what the chain rule says. You got to have another link where you do the derivative inside. Well, how do you do that? That's easy. Let the minus 1 come down here. This will be minus 225. Subtract 1 for the power. X to the minus 2. Way better than doing the quotient rule, which a fraction requires the quotient rule. So I rewrite it so it's not a fraction, make life easier. There's the derivative. Okay. Let's clean that up just a bit. So theta prime. Oh, by the way, they said d theta dx. That's the same thing. That's another way of saying the same thing. Two different notations they use in the world of calculus. So, all right. So I'm going to let this guy, it's over 1, right? So we'll just go up here to the top, multiply by the 1. So that's just going to be minus 225 x to the minus 2 on the bottom. 1 plus 225 x to the minus 1 squared. So there's the derivative. Now, last step, they say, okay, now that you got that, take 267 and pop it in. So I'm going to put in 267, 267, and hit the buttons on Desmos, and you'll get your answer, which they have right there. And so there we go. That one's not an easy one.